Hi, Andy. Can you hear us?
Yes, mate. All good.
Yep. Yeah, they haven't came yet, so and I don't think they showed a presentation yet.
Oh, I'm just sorting the camera at this side as well.
Sorry?
Just sorting the camera this side.
Okay. That good? The camera?
It's our side that's broken, mate.
Oh, okay.
I just with does it plug in? Or your presentation? You just need to plug in the laptop.
Oh no, we haven't got plug in. It's, are you going to do a demo? Or efficient presentation to place?
Let's
Share it out.
connect on the Wi-Fi. You have three dots.
Test, test. All right. Okay. Hi guys. Hello, everyone. For those of you who haven't met before, I think I see a lot of familiar faces. So my name is Yan, and I actually used to work here at Jersey last year. Unfortunately, I didn't work for very long, thanks to Brad. Where are you? There he is. So I met Brad last year, and he told me about this wonderful little startup called Yabo, where they were building this new social network that's a mixture of Twitter, Instagram, and Facebook. And he was telling me about all these wonderful challenges that they have right now, as well as in the future. So I jumped ship pretty quickly. Unfortunately for us, like most startups, the dream crashed and burned. For reasons that were entirely out of our control. You see, we had a billionaire investor who just one day decided to plug our funding, just as when we were showing good value, we were showing promise in the data that we had. But even as everything crumbled around us, we still managed to form a really good server team. And along the way, we learned a lot about how to develop applications with Lambda functions, but also more importantly, how to monitor and operate them in production. So when I joined the company, this is roughly what we had in terms of architecture. We had a couple of Node.js applications for the API, for some background workers, and a WebSocket layer. It all looks very simple on paper, but as you peel away the covers, you start to uncover all these complexities, interdependencies that's not obvious from the architecture diagram. And we were also in a peculiar place where, while we are a small network, social network, there's not that many users, but we do have a number of power users that had the tens of thousands of followers. So whenever they would do something, they would drive these massive spikes in traffic. So what that means for us is that from the operational side of things, we have to run our EC2 instances at a much average utilization level than we'd like. And since scaling up is really slow with EC2, you typically, I'm sure you guys are familiar with, it takes like what, 15, 20 minutes before an instance can start serving requests. And when we have all this massive, sometimes 70 times normal traffic spike within a 5-minute window, whenever someone runs a campaign that says, hey guys, vote on my post, and then at 10 o'clock, I'm going to announce the winner for this designer handbag. So pretty much exactly 10 o'clock, we get massive influx of people coming in all around the same time. Obviously, the system couldn't handle it, but because scaling takes so long, by the time we get a new capacity, most of the people have already come and left. So really, we got the worst of both worlds. And at that time, our deployment was also taking a long time, up to about 30 minutes, and required downtime as well, which in this day and age is clearly not good enough. And one of my favorite speakers, Dan North, once had this to say that the lead time to someone saying thank you is the only reputational metric that matters. It's a message that really resonates with me and has stuck with me ever since. But in order to get that thank you, we first have to deliver some value to someone somewhere. And to do that, we need to ship software. And until our code is shipped, as far as the users are concerned, we haven't done anything. But before we sit down and implement a brand new solution, a new architecture, we have to decide what a good architecture should look like before we settle on any implementations details. We came up with a list of criteria that I think must be quite familiar to most people here, that we want deployments to be small, to be fast, there shouldn't be any downtime, and we absolutely do not want to do any lockstep deployment with the client application, because that's just, that kind of coordination is just disaster waiting for happen. And we want features to be loosely coupled, and they should be deployable independently. And from the operation side of things, we want to cut out all the fat that we had in our AWS build, and we want to minimize the amount of time that we have to spend just babysitting our infrastructure. And we also had plenty of technical mess that we need to address. And notice that I didn't say technical debt. That's a very conscious choice of words here, because for something to qualify as a debt, you have to have had a conscious design decision and a plan to pay it back later on. And from what I saw, what we had was just mess. It wasn't a debt. There was no decision on, oh, we should do this rather than that, and this is how we're going to address it later on. So whilst we address all of these problems that we had on our hands, we still want to deliver value to our users. And in fact, we want to do it faster than we ever been able to do before. All of that is pushing us towards a very different style of architecture. And if you fast forward a few months, what we ended up was something that is an architecture that is event-driven and service-oriented, with AWS Lambda pretty much at the center of everything. It glues all the different components together. At that point, we had about 170 Lambda functions running in production, and we were paying for Lambda about 5% of what we paid for EC2 at the time. And the number of the deployments to production also went up dramatically, went from maybe doing 4 to 6 deployments a month to, I think, averaging about 100 by the time the company was shut down. So for the moment, we decided that, hey, Lambda is a pretty good fit for what we're trying to do, to having that first Lambda function actually running in production. We are professionals. We can't just say, hey, this thing is really cool. Let's throw it into production and see what happens. We have to be able to answer some of the questions that we had around how would the CI/CD pipeline looks like. And in this world where you don't have any servers and everything is running on Amazon Web Services, how are you going to do local debugging? How are you going to test your code? And what about all the operational concerns around logging, monitoring, and alerting, and so on? And from that point on, as our architecture expanded to include more and more services and more Lambda functions, we had to answer even more questions around configuration management. How are we going to secure our Lambda functions? And as you have services that depend on one another, how are you going to do distributed tracing and find out where problems are happening? So we're going to spend a lot of time talking about how we answer those questions. But for now, let me give you some context around what are the things that we actually build with Lambda. When I joined the company, the app already had a search feature. At the time, we were just one big regex query against MongoDB, which I'm sure you can appreciate is not going to scale well. And in fact, I think we were running into performance problems even with a relatively small number of installed users. I think at the time it was about 200,000, maybe 300,000 users or so. And it was really hard to do anything beyond rudimentary ranking using regex and MongoDB. So we decided to build a search feature from scratch. At this point, we've already migrating things into Lambda functions. So our legacy system at this point is publishing events to Kinesis whenever state changes. So whenever a user will follow someone else, whenever they post a new piece of content, all of those events are captured and streamed into Kinesis so that we can have a Lambda function, just listen to those things. And whenever a new user has joined a platform, or whenever they updated their profile or have a new follower, update their entry in the Cloud Search Index. And then we put an API in front of that so that you have a search API that the client can use. At the time, we also didn't have any analytics pipeline. We were using, I forgot what's the name of that service that we were paying a lot of money for. Do you remember what it was called, Brad? It wasn't very, yeah, it wasn't very good. So we decided to put together more something that we can actually use and something that's cost effective. So again, Lambda function, listening to events in Kinesis, and then live stream them into Google BigQuery. There was many iterations to this whole analytics pipeline. The first iteration took one developer 2 days to go from having that initial discussion about requirements to having something running in production. And it's also worth noting that this was the first time he's ever worked with Lambda functions. And after that thing went live, Chris, our BI guy, actually came to us afterwards and said, guys, this is amazing. I can't believe you got it done already. Nothing ever got done this fast at Skype. And which just goes back to the point of we should optimize for the lead time for someone being to say thank you for the work and the value that you are delivering. So as we got more comfortable working with Lambda and operating in production, we started to tackle other, I guess, more complex piece of work. In the app, there was a timeline feature, very similar to what you find in Twitter, where I post something and it will get distributed to my followers' feeds. Our implementation, however, was really complicated. It was pretty badly put together. It was so bad that the QA team just gave up testing it because it doesn't meet any of its criteria, and it just works in some mysterious way that sometimes it works, sometimes it doesn't, sometimes it works one way, sometimes it works another way. And by this time, Brett's already fired over the server teams, so none of the people that put that thing together was around. So we decided to sit down with the product team to really understand how they see this feature working, how it should behave, and what they see as the future for this feature. And we built it from scratch. In this case, take an example of whenever you post something, that becomes an event into Kinesis. And there's a Lambda function that responds to that by looking at, okay, there's a new piece of content from Brad, who are his followers, and who are the people that he's currently blocking so that we don't distribute his posts to those people. And then you batch them into, I think, groups of about 100 or 1,000. And for each of those batches, send a message to SNS, which trigger another Lambda function, which will actually add your post to your followers' timeline, which are stored as a sorted set in Redis. And the reason why we jump through SNS here is so that we can leverage the retry mechanism you get from SNS, and also to keep the stream processing at this layer flowing, even if you have problems distributing posts to certain users, because the way Kinesis works with Lambda is that if you fail to process a batch, it will just keep calling your function with the same batch over and over. And in many cases, we find that it's more important to keep the system real time than to making sure that everything you're trying to do succeeds 100% of the time. And to give you the ability to fetch your feed, again, put an API in front of the data with a Lambda function behind it. At this point, the client apps weren't able to update to the new API, so we also proxy the old legacy endpoints to hit the new API that we just put together as well. It's all about delivering values as soon as we can, and that's, oh yeah, right. This is hilarious. So most social networks give you a feature to say, hey, follow these guys, and I'm sure you've seen them in Twitter, Facebook, or LinkedIn. We had that as well, but our implementation was great. It was amazing because it will return the first 30 users from a database by account creation time. And it works great if you are one of the Yabo employees, which means you're going to come up in that list for every new user that installs the app. For most people, it's probably not very useful. So again, we decided to build it from scratch. At this point, we have all this data that's flowing into BigQuery. So what we had, we added a cron job which is the CloudWatch event triggering a Lambda function. I think once every hour, we should run a query against BigQuery to see who are the people that are currently trending the platform. So based on the number of new followers you've had in the last, say, 24 hours, and number of people that's liking your posts and so on. And we expose that data by, once again, API gateway. And whenever you follow or unfollow someone, those events are then streamed into and used to update as your social graph stored in the graph database. Graphene is the hosted version of Neo4j. And we put an API in front of that so that the client can use it to find, hey, suggest me people that I should follow or people that I should have start a conversation with. And once again, we proxy the legacy endpoint to hit the new API so that the old client doesn't have to get updated before we can deliver more value, some value to our users. So that's some example of just some example of work that we were able to implement with Lambda functions very quickly. There's a lot more where that came from. But let's switch gears and look at some of the things that we have learned. I guess the number one thing you should take away is that you should definitely try to use one of these deployment frameworks out there. The ones we use, well, not try to invent one in-house unless you have already, which in case, good luck. The ones we used was called the serverless framework. We chose it because ahead of Apex and a few other frameworks because it's a commercial company. They're well-funded, got full-time people working on the framework. And also, even at that point, I think a year and a half ago, they were already having a lot of community involvement, a lot of momentum from the community to improve the framework. And recently, they also added the multi-cloud support. Whilst you may hear a lot of people talk about how that's going to make cloud migration projects easy, don't believe that for a second, because as far as Lambda functions are concerned, your lock-in is not with the compute, with the Lambda functions themselves, it's with the whole ecosystem. With all the code that you don't write yourself, the code that involves your function from Kinesis events and so on. But what it does give you is the ability to reuse your tooling as you go from Amazon Web Services to Google Cloud in the same way that Terraform has great value. Even as you move cloud providers, you don't have to relearn your tools. So for me, that's where the multi-cloud support from the serverless framework is really useful. There's also Apex and then Cloudia and Zappa and Sparta. They all follow slightly different philosophy, and some of them support languages out of the box that others don't. Apex, for example, supports Go, and I think Zappa supports Python, but you get that with serverless already. The point is, go try it out, see which one works best for you, and as a company with 300 engineers, you should probably just choose one and stick with it so that anyone jumping onto a project knows exactly how to deploy your code straight away. As for testing, I actually read this book. It's one of my favorite books on testing. When I was here, we had the book club at the time. I think I read it with Billy, with Raj, and a few other people. I know Raj is not here anymore, unfortunately. But the book talks about the different levels of testing. You've got your unit test where you write tests around the object level to make sure that it's doing the right thing, to try the API before you actually go and implement those APIs. You can still do the same thing with Lambda. That doesn't change. If you've got some business logic, some complex code you want to test, just write a unit test around it. And then you've got your integration test where you want to test your code against code that you can't change. And when you consider a Lambda function, ultimately is still just a function that Amazon is calling on your behalf when some event happens in the ecosystem. So you get an event and a context object. So there's no reason why you can't call your own handler code from your integration test with a stub event and context object. The key thing to remember here is that since you're trying to test your integration points with other systems, you should be running your function in this context against the real downstream systems, not mocks. Otherwise, you're not really exercising those connections you have with the downstream system. And then you also have your acceptance test, where at this point you would have deployed your Lambda function and you're running tests end-to-end to make sure that the whole system is working. As you move up the triangle of testing, you get greater feedback loop, faster feedback loop for the developer. So unit tests give you much faster feedback loop compared to your acceptance test. But the different tests down below here give you much higher confidence that when you deploy your code, it's actually going to do what you think you would. And with Lambda, what we found is that you now have more and more integration points. more and more of the things that can go wrong exist in the configuration and the permission settings, as well as how you utilize, say, DynamoDB or whatever downstream systems you're using. So the return of investment on writing integration and acceptance tests is now much higher, whereas the function themselves becomes much simpler. So we found there's a lot less value in writing unit tests, or is focused on writing unit tests. So our general approach is to spend most of our time focusing on writing integration and acceptance tests, and we develop a very simple technique so that we can write the same test case and just toggle it so that it would be invoked via our own test code or via API gateway. So the guys, Steve Freeman, NetPrice, also have this to say that we find that tests that mock external library often need to be complex to get the state into the right shape. And that when the test is hard, it means that your code and your design is probably not right, but you're now carrying extra complexity for both your code as well as your test. And that is hard to get your mock to behave exactly the right way as the thing that you're mocking. And whenever you're updating, you also need to make sure that those behaviors are still valid. I think the same principles apply in a world where you're now depending on more and more services that you can't change, so that for me, at least, when you're writing tests, you shouldn't bother mocking your DynamoDBs and your Elasticache and so on. Just embrace the fact that those things, a lot of things that you're going to be testing, where they can go wrong is how you integrate with those systems, and just use the real downstream systems. And sure, as everyone is integrating and testing their code against the integration environment, all kind of things is going to break loose. But I'll say just embrace that chaos. That's what those environments are there for, so that you can identify integration problems early rather than much later on. Is everyone up to date on the Game of Thrones? Okay, good. We're going to say spoilers. Right, so on testing things end-to-end, Steve and Nat also have to say that wherever possible, an acceptance test should exercise the system end-to-end without calling into its internal code, and that the test should interact with the system only from the outside. So if you take the example of the search API we put together, where one of our test cases would be when a new user joins the platform, it should be searchable via the search API. So we would talk to the legacy system to create a new profile, the same way that a client application would, and that our test would be to validate that within a reasonable amount of time, that new user can be searched via the search API based on first name, last name, username, and so on. And as far as the CI and CD pipelines are concerned, I think there's a temptation to leave them really late in the project. At least I've seen this happen quite a few times. But I think since it's a mechanism for really saving you time as well as preventing human error, you should try to invest time into making sure that your CI and CD pipeline works much earlier in the project, so that you maximize the amount of time saving that you get from that pipeline. And again, going back to this wonderful book, it talks about how they prefer to have the end-to-end test also exercise the system and the process by which it is built and deployed. This sounds like a lot of effort, because it is, but has to be done anyway, repeatedly during the software's lifetime. Which brings me to one of my pet hates, where I see all these custom build steps exist only as a script on the CI box, but nowhere else. And inevitably, at some point, someone, maybe yourself, will try to make a change, break it somehow, but there's no source control, so you don't really know who changed it, when, and why. So I think all your build steps should be captured and should be source controlled the same way as your code. So for that, every one of our projects will have a very simple build script that just provides a thin layer on top of what the serverless framework and NPM gives us already, to drive our tests as well as to drive the deployment process. And since it's just a simple build script, it means that we can have reproducible builds that behave the same way when we run it locally as when it's run on the CI box as well. As for, for continuous delivery versus deployment, we decided that we don't want to, well, for most of our services, we don't want to deploy to production straight away. But we do want to, wherever possible, propagate the build once it's been checked in all the way to the staging environment, so that the QA teams can have a chance to run through tests with the devices. And also, we don't want to do deployments on Friday, because, well, if you mix B and the production deployment together, probably bad things will happen. And for each of those environments, you will run the test, you will deploy it, and then you run the acceptance to test things is working end to end before it kicks off the next environment and so on. And when you're writing Lambda functions, whenever you write to standard out, Lambda service will capture that and ship it off to CloudWatch logs. You also get additional information as well. And when you're writing logs, this way it doesn't add any overhead to your execution time, because Lambda is collecting them and shipping them off to CloudWatch logs synchronously. And with CloudWatch logs, you can find all your logs in here in one place, but what it doesn't do is make the logs easily searchable. And this becomes a much bigger problem as you have more and more services and more functions. And this is a common problem people run into in microservices. And the approach there is to have a centralized logging service where your logs can be easily searched. And the most popular solution I've seen around is Elk Stack, and I think you guys run it already, so you're familiar with the whole stack. With CloudWatch logs, you can actually go to one of the log groups and then stream it straight to Amazon Elasticsearch if you're using Elasticsearch. Otherwise, what you can do is to stream it to a Lambda function, who would then in turn ship it off to your own self-hosted Elk Stack somewhere. Another thing to keep in mind is that whenever you create a new function, it also creates a new log group as well. And what you don't want is a manual process for someone to remember to go to CloudWatch logs and click the button, subscribe, and so on. So what you can do is to enable CloudTrail and subscribe to the action of create log group with another function whose sole purpose is then to go to that new log group and subscribe it to your log shipping function. It's all well and good having all these logs floating around, but even if you take a relatively simple example of me posting a post to it showing up in my followers' feed, a lot of things have to happen, a lot of functions have to get invoked along the way for that to actually happen. And if someone was to come to me and say, hey, one of my followers didn't get my new post, what's up with that, Yan? I can go and try and debug it, but with all these logs everywhere, all over the place, it's really hard to construct the thread of exactly what has happened from the moment I press a post to it's getting distributed to my followers' feed, to him being to fetch it when he opens up the app, which is why you need the correlation IDs. And more importantly, your correlation IDs have to flow through all the places the invocation of your functions happen, which includes Kinesis streams, SNS messages, API gateways, and whatever other services that you're using. I think at the time when I was here, we were already collecting correlation IDs, but only through APIs, and they were starting to have conversations around how we're going to do that with SNS and Kinesis. I don't know how far you guys have got, but the approach that we took at Yabble was that we would just roll our own client library so that we can easily capture and forward the correlations IDs onward through different boundaries of HTTP, just as HTTP header. With SNS, you can include it as a message attribute. With Kinesis, it's slightly trickier because you don't get attributes, but what you can do, you just include it as part of your standard payload that you send to Kinesis. Amazon also recognized that this is a common problem people run into, so they announced the Xray service at the last reInvent. And it's a pretty great service. If you use it, you can see all the different things that happen within your Lambda function invocation. And in some cases, you can also cross boundaries to other functions that are handling SNS and whatnot. And you also get this nice service map out of that as well, so they can see your dependencies. As a request comes into your API gateway, calls a Lambda function, you can then see what are the different things that particular function calls as part of the invocation. However, as of right now, the traces you get from Xray doesn't span over API gateway. So if you were to call another API from your function that's handled by another Lambda function, you don't see the second invocation as part of your trace. I know it's something that they're working on right now, but as with Amazon, they wouldn't give me any timeline as to when I should expect this to be available. I also found there's also a couple other small caveats, which means that the Xray is useful, but right now it's hampered by the limitations you have with the service. But with a reInvent coming up pretty soon, I do expect some pretty big announcements to happen there. For monitoring, one of the things that we're used to doing is to install collect D, stats D, and so on, those agents on the EC2 servers. But without servers, or at least without the ability to access those servers, you can't do that anymore. And instead, you're pretty much relying pretty much solely on what you get out of CloudWatch metrics, which is not so great because CloudWatch has got a number of limitations. And whilst I've seen other providers try to offer support for Lambda functions, most of them, they just give you a better looking dashboard, but using the same data you get from CloudWatch. These guys are quite interesting. OwlPipe, what they do is slightly different. They give you a library that you can use to create your handler functions, in which case, when you create a handler function, they inject code at the start and the end of your invocations to collect metrics, and then they will send it to their own services so that you can see additional things that you don't normally see with CloudWatch, such as the amount of memory used, the amount of I think total amount of execution time that happens across your entire account. But having another thing that can potentially add the latency to my function calls that I don't control, I think that might be test. Okay, cool. We're back. Another thing that we are used to doing with collecting stats is having all these agents, collect them, batch them up, and then send them off asynchronously so that you don't add the latency to your actual, say, API handling code. Again, you can't do that anymore. I've found a couple of different ways to mitigate this additional overhead. And the best one I found is how Datadog handles custom metrics. Essentially, you can publish your metrics as custom log messages, and then you can have your log shipping function to also filter those out. And instead of sending them to ElkStack, you can then send them as a metric to CloudWatch or Datadog or whatever metrics thing that you're using. Once you've got your metrics in one place, you can set up your dashboard, set up alarms, hook it up to OpsGenie and ping them and so on. All the good stuff that you guys are doing already, including tracking lots of application level metrics. But I'm sure you guys are aware of this already, that the CloudWatch has got a number of limitations from a relatively primitive API dashboard, and also they've just announced having more granular interval for the metrics, but only for your own custom metrics. They are still working on making the service metrics that they provide from the ecosystem fine granular so that you can get 10-second intervals as well. And it also doesn't have some of the more advanced features, such as anomaly detection that you find with Wavefront and I think Stackdriver. But for me, the biggest reason to stay away from CloudWatch as your main place for all your metrics is that it has a tendency to go down at the same time as the thing that you're using as a monitor. So when you're having an outage, it's a terrible place to be in when you have no idea what the hell is happening and how it's impacting your customers. As for configuration management, nowadays, the main thing to remember is that when you consider a solution, you want to optimize for, well, maybe you want to maximize the ability to easily and quickly propagate any config changes across your entire architecture. When you create a Lambda function, you can create an environment variable. You can also have KMS encrypt those environment variable for you as well. But what we found is that this approach really doesn't scale when you have more and more Lambda functions, especially as those functions need to start sharing configuration values, such as if you're using the configuration value to say, okay, where a certain API is, very basic service discovery, then you put yourself into a position where, okay, every time those config value changes, maybe it's your SQL Server connection string, you now have to go and deploy every single function in all the environments, which is a really painful place to be in. So we actually that happened to us a few times where we changed our dev MongoDB a few times, and every single time it was someone's, whoever's on the BAU task that week, is his job to go in and update all these hundreds of, the tens of functions, which is no fun. Another thing we found is that for us it's okay, but with environment variables, you're coupling together one's ability to deploy a function with his access to the secret that you need to include as part of the deployment process. For us, we are a small startup. All the server developers have access to all the secrets for all the environments, so it's not so much a problem for us. But imagine for a big organization, maybe even you guys, this can be a potential problem whereby a developer have to have access to all the credentials and API keys and so on for the production environment, where you probably want to restrict it to access to those to a much smaller pool of people. And it's hard to do that with environment variables. Again, this is a common problem people run into in the microservices world, and the approach there is to have some sort of centralized config service. And when we looked at the different solutions available to us, I looked at console, I looked at XCD, but ended up deciding to just roll a very simple config API with API gateway and Lambda function, because it's far cheaper and we don't have to run, well, because with the other service solutions, you have to run multiple instances of EC2 servers across different regions for HA, and also means that you have to manage and maintain those clusters yourself, and not to mention there's a certain amount of learning curve involved with each of those tools. They are all very powerful, but they do way more than what we actually need. So we decided to just roll our own at a time. And since then, Amazon also announced the EC2 parameter store at the last reInvent quite a few months after we rolled our own thing. So nowadays, if you're looking for something to manage your configurations, then maybe do consider EC2 parameter store as the first option. We also invested time into making a very robust client library for the config values, include caching, as well as the ability to hot swap config values, so that whenever you update, say, MongoDB connection string for dev, that gets propagated to all of your functions without having to restart and redeploy them, and so on. And where you have secrets and credentials and API keys in those configurations, you should make sure that they are encrypted at rest as well as in flight. And this is also important as well, especially when you have a large team and people turn over, to give them role-based access rather than something that everyone can just store on their laptop. So whenever, I don't know, Brad walks away from here, you don't want to be in a situation whereby all these secrets are on his laptop somewhere, or maybe he's copied it somewhere else, and you want instead to have those secrets to be given a role-based permissions. You can do that with KMS. And you get that out of the box with EC2 parameter store already. When you store a secret, you can store it as a secure string, in which case you get encrypted with KMS, and you'll be stored encrypted at rest. And when your function retrieves it at runtime, you also communicate this through HTTPS, and you can also have the function being responsible for decrypting the secret as well. I also found a number of plugins for the serverless framework for managing secrets, but from my experience of those, they don't seem to meet the requirements that I have in terms of the ability to quickly propagate changes and having fine-grained control over who can access those secrets for production. What's the time? How are we doing on time? Let's see. Okay, 1:45. So I guess we still got some time to go through some other such miscellaneous things I've learned along the way. For the serverless framework, one thing to keep in mind is that you have 75 gig total deployment package limit per region for Lambda. And okay, one of the things that we did was that we found, even with our small team of about 6 server developers, we're doing deployment so many times a day, and every time you deploy with a serverless framework, by default, it creates a new version, therefore increments your package size, overall package size, just that a tiny bit more. Even if every function was about 2 meg in size, over I think 2 or 3 months, we managed to rack up about 20 gig of deployment packages. So we had to find a solution to clean those up. And you guys probably heard of Janitor Monkey from Netflix. So I took a leaf from their book, and I wrote the Janitor Lambda function, which goes around and delete all versions of your Lambda functions that are no longer referenced by an alias. And nowadays, with the version 1.x of serverless framework, you can also disable that default behavior of creating a new version every time you do a deployment. And frankly, for non-production environments, those different versions doesn't add any value at all. It just adds to your cost and maintenance overhead. And the good thing to do is to install the serverless framework itself as a dev dependency for each project, so that whoever that's going on to the project can deploy your code without having to have that specific version of the serverless framework installed either both locally as well as on the CI box. So it also helps you deal with, I guess, avoid all these version conflicts when, so for example, if your project is using serverless 1.5 and now a new major version is out and it's breaking changes, so you now need to have both version 1.5 and version 2 or installed locally to be able to deploy that older project. But with this approach, you won't have that problem. And also, since 1.16, serverless framework also added the ability, well, the behavior to exclude dev dependencies when you're building a deployment package, so they don't add to your package size. And with the serverless framework, you also have the command to invoke a function locally with some arguments, and combine that with the ability to debug Node.js code in the VS Code. It means that you can actually debug your Lambda functions both running locally and also debug it locally as well. And this happened the other day. Amazon announced the SAM Local, which is their own, I guess, tooling for running and testing Lambda functions locally with different event sources, I think including SNS, S3, API Gateway, and so on. I haven't really tried it out myself, but the link is here. I'll share the slides afterwards, so you guys can go and check it out. As far as performance is concerned, one of the, I guess, the main topic around performance is co-stars and how they behave. So if you look at your function invocations with Xray, you see the first time the function is invoked, this massive gap in time before your code actually runs. That's what we commonly refer to as the co-star time. Even though the Lambda guy don't go into details about the implementation details under the hood, that explains how the co-star stuff works. The OpenWhisk guys has been talking about it pretty openly, and I'm pretty sure that it works exactly the same way, that you got a certain amount of time involved to start a container, and then once the container is started, there's a certain amount of time involved with starting up your actual runtime, initializing your code, and so on. I'll do some experiment to see how long if your function is not being invoked regularly, how long AWS Lambda keeps your functions around. And before, I think, at least at the time Yabba was around, it was about 5 to 10 minutes. So co-star is quite a common problem that people have to actually address. But since then, they've changed it. And what I found is that now your idle functions are kept around for about 45 to 60 minutes. And even if your function is actively being used, Lambda still recycles it after about 7 hours of it being up. Again, those are implementation details that can change with any moments of notice. So do use them to understand the platform and characterize the platform, but don't build your application with those assumptions in mind. Another thing that I learned with using Lambda is that it should really embrace the dynamic languages. And one of the main reasons for doing that is that I found when I compared the co-star time across the different languages, runtime, different memory settings, and package size, Java and C# is up to 2 orders of magnitude higher co-star time compared to Node.js and Python. And once they're warm, there's actually very little performance difference between the two. But I hear you asking, but what about type safety? And until the guy that goes to conferences and tell people about using type to make the illegal state unrepresentable, impossible. And all those arguments are still valid if you're building a traditional application. What I realized is that with your Node.js or any other languages, when you're building an application, the complexity ceiling can be really high. You can make that thing really, really complex, especially with all these different frameworks and different ways of doing routing and so on. And a lot of things that I love about F# in terms of referential transparency, type inference, and all the different nice type systems you have, they are tools to help you manage that complexity. What Lambda does is that it approaches this problem with complexity from a different angle by really limiting how complex each thing can be. So each function can't get that complex. Then maybe you won't need all these fancy tools for managing that complexity. So going into Yabba, going into Node.js, using Node.js, I was actually quite scared. In fact, when we looked at our legacy system, the Node.js code, we had I didn't understand what the hell is happening. I see a variable called the user, but depending on where I see that variable, it does something completely different. It's a different abstraction. I have no way understanding what I can do with that user object at each of these places. But with Lambda, our code is typically 2 files deep. Whenever invocation happens, it goes into the main module, maybe calls another function from another module somewhere, but that's about it. In terms of your complexity ceiling, it's very, very low. So I actually found myself didn't missing any of the types, any of the type inference, all the nice things I get with F#. So going back to cold start, I guess the thing to remember is that because of the ephemeral nature of Lambda functions, you should avoid making any hard assumptions about the lifetime of your function. That said, Amazon Lambda does reuse containers for automation, so you do have that local state you can take advantage of, and I think you should use it for automatizations only. But don't make the assumption that that local state is going to be there from invocation to invocation. As example, we had a system whereby we would have a process event whenever you drop a file into S3, and that file can be, I don't know, several hundred meg in size, and that contains millions of people that we need to send a message to. And rather than having every invocation then go to S3 and download this massive file, we will just keep it in memory. So the next time when we recurse, we written the function as a recursive function, we check, okay, do we have the state in memory? Does the E tag, is it the same? If it is, then we have the latest data for that particular file. We can just proceed with the data we have in memory already. And in order to avoid the cold start, you can have a simple cron job that runs every few minutes, hit the Lambda function, and all that thing does is ping other functions, maybe API, user-facing APIs that doesn't get used very often. We have this API that returns I think the terms of conditions in different languages, and obviously no one ever checks the terms and conditions of the app, so that thing doesn't get used at all. But of the chance that someone does go there, they have to wait 4 seconds because of cold start every single time. We also run into this problem in our dev environments where, again, client developers don't use the APIs all the time, but whenever they do, the first time they run it, they get hit by the cold start time. So this can be a useful thing to do. It's not so much a problem nowadays because of the 45 to 60 minutes, but before when it was 5 to 10 minutes, it was kind of a big issue for us. Oh yeah, so what you do is to keep the functions warm, and you can also integrate with some logic to do health check as well for your functions. Lambda's got a hard limit on how long you can run your function for, and that's 5 minutes. So if you need to run something that's for longer, then you can write your function as a recursive function instead. Same principle, you just invoke your function at the end with some payload that tells you where you finish off with the last invocation, so that in the next invocation, you continue off from there. If you're using Kinesis with Lambda, one thing to keep in mind is how Kinesis handles retries. Well, we talked about that before, where if your function errors, it would call your function again with the same batch until you're able to process it successfully or until the data in that batch has expired. Which brings the question of what do you do with partial failures? You get a batch of 10 records, you process them, 9 of them is okay, 1 of them fails. What do you do? One of the things that you could do is you can wrap your processing logic into a shared library within your serverless project, and you have 2 functions with represent different entry points, so that you can give that fail record a few more retries within the function, and if it fails, pump it off to SNS as a message, so that another thing that can pick it up in the background, and you can leverage SNS as a retry mechanism, so you can fail if you want. And after 3 attempts, it also goes into dead letter queue as well. One of the things that Amazon doesn't support right now is SQS as an ingress source for a Lambda function. So once you've got your dead letter queue support, you still have to hook up some alarm so that someone knows, okay, some stuff is failing, let's go and figure out what the hell is going on. But we really wanted to use SQS because as a service, it still has a place in our ecosystem. So we prototyped the architecture for processing SQS messages with a recursive polling function, and have a way to scale up and down the number of concurrent pollers that we have based on the number of messages in the backlog in the SQS. You can read all about it in the blog post I wrote a while back. With Kinesis, another thing to keep in mind is that each shard in the stream can only support 5 reads a second, and by default, Lambda posts Kinesis stream 5 times a second for each function. So by the time you have, and each shard has a dedicated instance of your function running. So by the time you have a few Lambda functions all subscribe to the same stream, we start to see the number of reads throughput exceptions really goes through the roof. It doesn't impact us per se because these are all happening transiently between Lambda and Kinesis. But where it does become a problem is when, say, a particular function is just being unlucky, constantly getting throttled whenever it's trying to read from a stream. Then you have a massive spike in the iterator age, which is the time between event getting sent into Kinesis to when your function has received it. So having this kind of spikes can mean that your system appears no longer real time for some fraction of time when it affects a particular function. One of the workarounds the Amazon guys told us, hey, you can just have you can put a subscriber and then have that do the fan out instead. But remember we talked about partial failures being a tricky question. In this setup, partial failure is going to get so much worse. Each one of these guys can have partial failures within a batch. What the hell are you going to do at this guy? So this is probably not a good idea. It's probably not a good idea. It's one of those last resorts you can probably use, but you should probably find something else. Another approach I found is from the guys at the Cloud Academy. They've got this nice, clever thing where they use Kinesis analytics to then essentially fan out the input stream into many streams so that you can have end up with 1 stream per subscriber without the subscriber with just Kinesis query. Kinesis analytics query. It's very clever, but it means now you have many more streams, and each one of them is starting to cost you. So from a cost point of view, it does have a significant implication. And the decision that we ended up reaching was that we decided to look at some of our streams had 11, 12 subscribers, and we decided to look at each of those subsystems to really ask the hard question, does it need to be real time, or is it doing a more task-based processing where the order of events in which they're processed doesn't matter? And for those, we decided to use S3 or SNS or some other event source instead. So that's all I'm able to squeeze in about an hour. I am running online course with Safari Books online next month, and then again in October. It's free. You've got an account with Safari Books, so check it out. And I guess I think we're up for time now. It's almost 2 o'clock. So thank you. Got a few minutes. You guys got questions? Oh, yeah. 6.10.
So how would you deal with?
So the question is this working?
Yes.
So my question is, were you using that across all your Lambda functions, same version everywhere? Pretty much.
Pretty much. We started off with 4.7. The version number for how we searching. We started with 4.7, but then sometime after we started, Amazon supported 6.10, so we made a switch all of our projects to 6.10.
So winding that forward, when you've got however many functions, how do you envisage dealing with the situation when Amazon go, right, we're deprecating 6.10, and you've got 1 month, which is essentially what happened last year with 0. whatever it was.
It wasn't 1 month, though. They gave you plenty of time. I think it was at least several months before they deprecated it. In fact, once they announced 6.10, we got an email from last month saying that, oh yeah, we are definitely going to deprecate 4.7 now. We still got some functions. But given the fact that we've got team ownership of the particular group of functions, then I would say you can split that work out across different teams. So if you're looking after the public API, let those guys deal with their own functions, and someone that looks after basket or whatever, have those guys deal with their own functions. So for us, we had a small team where sort of ownership for all these functions is kind of distributed, even though we kind of count it up in about 2 or 3 to work on a bigger feature. So again, we just split it up across the teams to say, okay, you look after that API, those bunch of services, you update them. And also, in terms of updating, that's really not much change. There's one config change. You may even be able to just get all of your repos into on your computer and just go grab and change.
And just deploy it to production straight away.
Not the production. That's why you have the CI/CD pipeline.
Yeah,
and then you do it on Friday, or when you have a clear, let's go do this. Let the sound say nothing.
Yeah.
Okay, good. Anyone else?
Have you run into a way to beta test new versions on a certain % of traffic? So say 5% of the traffic going to a new version of the function.
Not out of the box. So that's some of the things that Amazon, a lot of people have been asking Amazon for, is to have the ability to do canary. So with Lambda, they can't do away with the need for doing blue-green because they do it for you, but you still want to say, okay, I've got 1 million people using my app all the time. When I put a new thing out, I don't want to hit everyone at the same time. So that if I've got a bad thing that I have a bug that I haven't found out, I want to hit just 1,000 people. You can't do that yet. I've tried very hard. In fact, I tried so many different combinations of things. It doesn't work because the problem lies with API gateway and cloud front. That I tried all having Route 53 mapping from the group domain to my canary production domains, all kinds of different things. It doesn't work. You may be able to do it with Lambda at Edge, but when I think about it, the only way to do it right now is to do some kind of a routing within your own handler code. So essentially, you'll probably ship your handler code, both new version and the current version side by side, and then in some configuration in the routing in the module code, you say, okay, right, you are in that 5%, so your request goes to the new version, everyone else goes to the old version, and then use config management to toggle them and hot swap the configuration. That's the only way I see you can do it right now. I spoke to Heitor, who used to be the technical account manager here, and basically told me flat out, yeah, don't bother doing it right now, we're going to solve that. So it is coming. I just don't know when.
Yeah, with the testing triangle, which you kind of flipped, how much extra time did you have to spend trying to find out when something went wrong with, say, your acceptance test? You know, because
the problem itself doesn't take very long, but the running loads of different test cases does take quite a bit of time, especially with our legacy system. We keep running into performance issues on that system for some reason in depth, but we're talking about maybe a few minutes sometimes. So it's quite painful. That's why we should have regression tests with the same test cases that you go locally, hit the real downstream system, like on 3D and up, find out there's a problem there. So hopefully the only thing that can go wrong is your configuration and being say API gateway and Lambda function itself, and maybe the permission setting for the Lambda function itself. Maybe it's missing permission to run it down into the table. Okay, all right. Right, I forgot. He's still here. He's still doing those interesting work with the serverless framework. Where was I? Right, so testing. So hopefully you should catch most of your bugs with integration tests, and because you can also run debugger as well. So that means you can trigger in your VS Code configuration to say run npm framework Mocha, run my integration test, so that if there's any failures, I can put a debugger to see what's actually going on. And then hopefully the only thing that you need to catch with the acceptance test, which takes a long time, are configurations and permission settings. So it's definitely much slower compared to writing unit tests, but then again, I find unit tests, especially with Lambda function, just gives me a false sense of security that everything looks green, but the moment I run it against a real downstream system, it breaks.
Next one, have you seen any way to protect against a bad actor Lambda taking up all of your execution quotas?
That's a great question. No, and that's something that I'm sure Amazon is working on. That's one of the things that you can't really, because the invocation is not up to you, is coming from the API gateway, is coming from S3. In fact, I've read a few times where, and this hit us a few times as well, where if you're, say, subscribing to an event of some object being dropped into S3, and you happen to be dropping the file from your function to S3, or doing something similar, and then you end up with a recursive invocation. And I've heard a few people, I think once someone actually posted something that got shared on the last week or in AWS the other day, that, yeah, he's his own personal project, and he racked up, I think, about $200 or something overnight, which is pretty small, thankfully, because Lambda is quite cheap, but still, at a bigger company, your problem would be, okay, now I can't invoke certain critical systems because all my execution is used up. So Amazon, I'm pretty sure, is working on that. Right now, there's no good way to do that. One thing you probably could do is to separate them by account, which then brings other problems. Then you question, okay, is it really worth doing that? Okay. Any more questions?
Sorry, one more.
Okay.
Management tooling. Did you have to build any management tooling around things like redriving messages in SNS or looking for failures of messages, that sort of thing? Or wasn't it necessary?
We didn't have them at the time. Now you get the dead letter queue, so potentially you can do that. So at the time, they also didn't have dead letter queue support. It was only added, I think, earlier this year. So now what you probably could do is to have a dead letter queue for all of your async sources like S3, SNS, and so on, and have some alarm set up so that someone can manually investigate failed invocations and then maybe retry them later. So one of the things I find with things like PubSub and push-pull patterns, I find with things like S3 and SNS, the problem you have is that you are vulnerable to temporal issues. If downstream is having a problem, all your invocation is going to fail while that downstream is having trouble. Or if you are more scalable than your downstream system, which could be a SQL database, it could be someone else's API running on EC2 that can't stretch quite elastically and quite quickly. What you probably can consider is use a different source. So where Kinesis is bad, if you want to just keep things flowing, it's great if you want to just stop if things are failing and don't let it proceed until things recover. So that's one of the things you probably could do. And you can also use the dynamic DB stream as well, but that comes with its own caveats as well. There's just so many different options you can choose, so it's sometimes quite confusing. You have to look at the different characteristics you get from the different sources. Okay, any more questions? Okay, one more.
Slightly different question. How do you share the logic across the different components in your microservices architecture?
Okay, so how do you share logic between different functions? You get sharing out of the serverless framework. The way you typically structure your project is you have one repo, and then you have one service which consists of many different a few related functions. So you can share logic just normally by modules. Outside of that, you can use NuGet packages or npm packages to share logic. Cool. So if there's no more questions, I think we're just going to call it a day. You guys can reach me over Twitter, Facebook, or whatever, or just ask Brad. I see him regularly. Okay, cool. Thanks for having me.